Hi, this is Don, and I want to work for you a difference of two means problem in section 8.1. And here we have the problem, and we've got to find the test statistic, the standardized test statistic, and decide whether the standardized statistic is in the rejection region and whether you should reject or fail to reject. Samples are random and independent. And there's our data. mu1 minus mu2. There's the claim. They're equal. Or mu1 minus u2 is 0. And the null hypothesis then is, that is the null hypothesis, and the alternative would be they're not equal to 0. The data we have is the mean of the first sample is 18. Its standard deviation is 1.3, and n is equal to 50 for that sample. For the second sample, the mean is 15, standard deviation 1.8, and again, n equal 50. So let's go to the first question. The test statistic is 3. Well, how do we get that? Well, the test statistic for a problem like this is very simple. It's just the difference in the two means, x1 minus x2. 18 minus 15 equal 3. Ta-da. Okay, standardized test statistics. There's two ways to get it. One is to do it manually using Excel, and the other is to use StatCrunch. I'm going to show you the manual method first of all. Okay, here's the spreadsheet. I've copied over the data, the alpha of 0.05, which actually we don't need in this solution, but I just copied it anyway. Our average, or the mean of the first sample, x1 bar is 18, x2 bar is 15. Standard deviation of the first sample is 1.3, 1.8, and the two n's are 50. And here is the formula. We've got a large samples greater than 30, and we know we have a normal distribution, so we can go ahead and you can see the formula there. There I've solved the test statistic, 3, and now we're going to standardize that using this equation. There's your test statistic right there. mu1 minus mu2, we say they're equal, so that's 0. And then sigma x1 bar minus x2 bar is equal to the pool, and we just substitute s in there. Let's solve for the sigma here, sigma sub x bar 1 minus x bar 2. Here is the Excel formula, kind of complicated, but you'll see that it's just we're doing this sigma or s 1 squared over n1 plus s2 squared n1. And that's the value. B4 is s1 squared. B6 is the n value for the first sample. B5 squared is the 1.8 divided by the 50, which is this there. And we get 0.34006. And I'm going to let Excel keep all the decimal places. Then we solve for the standardized z. And that's this equation here where we've already solved for this. And so that makes the Excel formula a lot simpler. It's just, again, our test statistic, B1 minus B2 minus 0 there, and divided by the value that we got for our sigma pooled. And that is a 9.533. All right, we're back in my stat lab, and I brought over the standardized test statistic of 9.55 after you rounded the two decimal places. We already had the test statistic, 3, and the question is the standardized test statistic in the rejection region? Well, what is a rejection region? Well, they gave us alpha 0.05, and we could go into a standard normal table and pull out the z-critical values, which would establish the rejection zone. But they've given it to us in this diagram over here, our normal curve, and we see that the z-critical goes from minus 1.96 to plus 1.96. And because we've got a two-tail test, the rejection zone, these blue areas on the two tails. So is 9.55 in that area? Well, yeah, 9.55 is way over here somewhere. So it's definitely in a rejection zone. Should you reject the null hypothesis? Yes. We reject the null, and at 5% level of significance, there is enough evidence to reject the claim, which is the null. Okay, on the next video, we'll do this problem using StatCrunch. Be right back.